And welcome to Unit 9.1, Part 2. This time we're going to continue our discussion with polygons on the coordinate plane, but we're going to actually do area and solve for area and solve for perimeter and more of the dimensions of these shapes this time. So go ahead, copy these 4 problems down onto your notebook paper or onto your printed version of these notes, and treat this as your bell work. So go ahead and try to solve these and put your video on pause. After you come back, let's go ahead and check your answers there. So if we look here, this first shape is a parallelogram, and we know that the parallelogram is simply a four-sided shape, and our area then is base times height. But our base and height have to be perpendicular to each other. So for our first one, we can clearly see that 4 represents the height of our shape, but 5 is the base that goes with it because they have to be perpendicular, meaning they have to have that 90 degrees between them. So in this case, this 4.5 becomes irrelevant. So we can go ahead and say that the area of this shape would be 4 inches times 5 inches, which would give us an area of 20 square inches. So make sure you have that one there. Number 2, we don't necessarily know where the divide is here for these triangles. So let's go ahead and think outside the box or inside the box. And let's go ahead and draw ourselves a box around this whole thing. We do know that the area of a square or a parallelogram is equal to base times height. And we do know that the area of a triangle is simply equal to base times height divided by 2, or 1/2 base times height. So let's go ahead. Let's do the area of our square would be the dimensions of 25 by 25. So we would have 25 times 25, and that would be for our square. For our triangle, let's go ahead. We can think of this as our base of our triangle, and this as our height, which are simply just the sides of the square. Okay, so this would be 25 times 25, all divided by 2. So for our total area, we're going to do our square, which is 25 times 25, which is 625, minus the white area of that white triangle, which would be 25 times 25 divided by 2, which is 312.5. And once we go ahead and subtract those, we'll have the area of the blue shaded region on your diagram, which would be 312.5, and this would be square feet. So make sure you have that one for number 2. For number 3, as we look here, we're going to go ahead and break our shape up into a couple of different easier shapes. We're going to do a square, and the area of our square is simply going to be, what's a square? 8 times 8, which would give us a total area of 64. So we can also break this shape up into the area of a triangle. And our triangle, well, if this is a square, this would be an 8 dimension, a dimension of 8. And then this 14 stretches all the way across. So if we take the 14 and we get rid of the 8, we're going to have 6 left. And we know those are perpendicular because this angle right here is perpendicular. So the area of our triangle is going to be 1/2 times base of 6 times a height of 8. And in this total case here, we're going to go ahead and do our total area then of 8 times 8, which is 64, plus the area of our triangle. Half of 6 is 3. 3 times 8 is 24. So our total area would be 88 square centimeters. So check and make sure you have that one correct. Last but not least, we have this triangle over here. This would be the height of our triangle, and then this would be the base of our triangle. We can see that our base is going to be 12 because it'd be the 6 and the 6. But our height is not 10, and our height is something we need to find. But if you look here, this is a right triangle over here. So we can go ahead and use Pythagorean theorem to solve for h. So we could say h squared plus 6 squared equals 10 squared. So h squared is going to be equal to 100 minus 6 squared, which is 36. So h is going to equal the square root of 64, which is 8. So now for the area of our triangle, we'll do 1/2 times our base of 12 times our height of 8, and that gives us half of 12 is 6. 6 times 8 is 48, and this would be square meters. So make sure you have that for number 4. Continuing on, let's talk about a parallelogram. So we can still use this area equals base times height. And remember, base must be perpendicular to the height. If you don't remember anything else today, remember that. So if we look at number 1, we're asked to find the missing dimension. So we're going to solve for h. H is a height, and it must be paired with a perpendicular base. Well, the only perpendicular side is 0.5. So we know that the area of this thing could be our base of 0.5 times the height. But we can't use that. We need to figure out how to actually solve for that missing dimension. So let's look at our shape again. We have this 0.4. 0.4 could represent the base of our shape. Now, the height that would be perpendicular to that, we don't have. But we do have this other dimension marked over here, which is showing how tall our figure actually is. So this would be the height that would go with that. So we can also say that area is equal to a base of 0.4 times 0.3, which is a height. Now, both of these should be the same because they're coming from the same parallelogram. So we can go ahead and say that 0.4 times 0.3 actually equals 0.5 times h. And then in this case, we can find our missing dimension. We can do 0.4 times 0.3, all divided by 0.5. And then we get a missing dimension of a height of 0.24 units. So that's for number 1 there. Number 2, you're going to do the same process. H is what we're trying to find. Well, this is technically a height, and it should be perpendicular to whatever this is, but we're not quite sure what this is. But we can look down here, and it's actually perpendicular to this side. So we do know that the area is going to equal a base of 10 times a height of some unknown dimension. And when we do that, we can also match up this height with this base. Oh, but it's also perpendicular to this one. So we can also say that the area is equal to 8 times 14. And once again, these are the dimensions of the same parallelogram. So we can go ahead and say that the two formulas should be the same. We could say that 10h should equal 8 times 14. So then our missing dimension here would be 8 times 14, all divided by 10. And when you put that into your calculator, you get 8 times 14 is 112, so then you would get 11.2 units. Make sure you have that for number 2. Let's go ahead and move forward here. So on this one, it says we're going to work backwards. So it says the height of a parallelogram is 4 more than its base. If the area of the parallelogram is 21 square meters, okay, find the base and the height. This is a little bit of a challenge problem, but you guys got it. So if we have a parallelogram, we could say that the height and the base are the dimensions that we're going to find. So we know h is here, base is here. But this time we were told that the height was 4 more than the base. So we could actually call our height 4 more than the base. And we know that the total area is 221. We also know that area is equal to base times height if the base is perpendicular to the height. So let's go ahead and let's put some values in here. We know that the area, 221, should be equal to the base, some value we don't know, times the height, some value we also don't know, but we can write it in terms of our base. So if we multiply here, we're going to get 221 is equal to 4b plus b squared. Think back to your deep, dark days of Algebra 2. If we were to subtract this 221 over, we'll have 0 equals b squared plus 4b minus 221. What do we do here? We could do quadratic formula, we could factor, we could do all kinds of things. Let's go ahead and factor because this expression is factorable, or this equation is. So if we go ahead and factor, we know b and b are going to go here. This sign is telling us that we're going to have a positive and a negative sign in here. And we now need to think about the fact that we need factors of this term, so factors, meaning two numbers that multiply to give us this value, that also add to a positive 4. Well, for those of you who are sitting there typing away in your calculator, go ahead and keep continuing to do so. If you get down to the fact where you have 17 times 13 is equal to 221, we can go ahead and make this a positive 17 and a negative 13, because 17 minus 13 gives us a positive 4 for that middle value, or our b value. So now, for each one of these, we would say b plus 17 equals 0, and we would say b minus 13 equals 0. So we have that b could either equal a negative 17, or, let's erase that, that looks a little sloppy there, or we could have the fact that b could equal a negative 17 or a positive 13. Now, b is actually representing the length of something on a shape, so we can't have a negative 17. So we would say that our base is equal to 13, and we would say our height is equal to 13 plus 4, which is 17. So then we've now found the base and the height of our parallelogram. A little bit of a challenge problem there for you, something to think about. All right, so let's go ahead. I'm actually going to hop out of here for a second because I'm going to skip forward to a new part of our section. We're going to go ahead and transition to actually putting these shapes up onto a coordinate plane. Now, as a quick review, we're going to be finding perimeter and area of these shapes. And as a quick review, we need to make sure that we understand how to use the Pythagorean theorem to find the length between 2 points, or the distance between 2 points, which will be representing the length of a side of a shape. So, length or distance, you can plot your 2 points, all right? Make a triangle. Make a right triangle between your 2 points. Go ahead and count your sides, or you can simply look at your coordinates. For this one, it's at -2, 6, and then b is at 8, -3. So let's go ahead, I'll rewrite that here. Okay, so 8, -3 is the coordinate we have for b. So we need to label the lengths of our side of our triangle. Now we can count these, or those of you who don't like to count, you can just look at your coordinates. Moving horizontally, we're going across the x-axis, so we need to figure out the distance between a -2 and an 8. So between -2 and 8 is a total distance of 10, okay, or you can count them. Vertically, we need to figure out how far it is from a +6 to a -3. Well, that would be a total distance of 9. So then to find the length between AB should equal the C value of our triangle. So we could do 9 squared plus 10 squared equals C squared. Now, some of you are getting to the point where you can kind of shortcut this. We know we're going to actually square these two values and add them, and we know that the C value, we're going to have to take the square root of it in order to solve. So some of you are getting good at the fact that we can say C is equal to the square root of 81 plus 100, or C equals the square root of 181. Okay, 9 squared was the 81, 10 squared was the 100. So if you do the square root of 181, I believe you get 13.5. So go ahead and put that into your calculator. Square root of that, yes, gives you 13.5. So that's just a quick recall of how to find the distance between 2 points. All right, let's go ahead and move forward. Let's go ahead and apply this to finding area and perimeter. So this time we're going to find the perimeter and the area of this shape. We have a trapezoid on our graph. Let's do the perimeter first. It is very, very important that we round only our final answer to the nearest tenth. So here's our coordinates. If we look here for perimeter, perimeter means we're adding up all the sides. This one's pretty simple. So from x, we're going from a coordinate of 2 to y, which is a coordinate of 9, or we can count 1, 2, 3, 4, 5, 6, 7 is our unit here, and then we can also easily label this side as 1, 2, 3 units across the bottom. Now, to find these diagonal sides, remember you can't count the boxes, they're diagonal. So we're going to go ahead and if we make our triangles, see if you guys can see yellow. If we make our triangles, we're going to have a 1 by 1, 2, 3, 4, 5 triangle. It's pretty rough, I'm sorry. All right, so we'll have a 1 by 5 triangle, and we can then use Pythagorean theorem. So this is 1 by 5. We could call this our C value. We know that 1 squared plus 5 squared equals C squared. So C is going to equal the square root of 1 squared is 1 plus 5 squared. 5 squared is 25. So this will be the square root of 26. Notice I'm going to leave it as the square root of 26 because I don't want to round in the middle of my problem. If I round in the middle, I'm going to throw the whole thing off. Come over here, and we're going to make one triangle this way. This is a 3 by 5. So this C value is going to equal the square root of something. Well, 3 squared plus 5 squared equals C squared. We know C is going to be the square root of whatever we get here. 3 squared is 9. 5 squared is 25, so this would be the square root of whatever 9 plus 25 is, or 34. So now for our perimeter, make sure you go ahead and save this for your calculator. Make your calculator do all the work. We would do 7 plus the square root of 26 plus the 3 plus the square root of 34. And it says nearest tenth. So if we did this and we rounded to the nearest tenth, we're going to get approximately 20.9. Now, for the area of this thing, we need to figure out a way to go ahead and break up our shape into shapes that we know how to easily find the area of. So if I break this up into a rectangle, this is a rectangle and the dimensions are 3 by 5. So for our area, we can do the area of the rectangle plus, let's go ahead and call this triangle number 1, and let's call this triangle number 2. So plus the area of triangle 1 plus the area of triangle 2. So if I was to find the area of these, well, my rectangle is simply a dimension of 3 by 5. So I'm going to have 3 by 5 plus the area of triangle 1. It's going to be 1/2 times my base of triangle 1, which is 3, and my height of triangle 1, which is 5. Now, if you look closely, we already had 3 and 5 going on. So using this Pythagorean theorem method actually helps us. So plus the area of triangle 2, well, triangle 2 has a base of 1 and a height of 5. So this would be 1/2 times 1 times 5. So our total area, 3 times 5 is 15, plus half of 3 would be 1.5 times 5 gives you 7.5, plus half of 1, which is 1/2, and then half of 5 is 2.5. So our total area is equal to, if you put that into your calculator, or some of you can just go ahead and read there. you should get a total of 25. Now, we don't know what these units are. They didn't tell us on the graph if it's like centimeters, inches, or whatever. So we would just write this as square units, UN squared. And for perimeter, we would just go ahead and write this as units, UN. Let's move forward. Let's try a triangle now. So Dylan is fencing a chicken pen. Determine how much fencing Dylan will need. And we're assuming that the distance between grid lines is equal to 1 whole foot. So the first thing is we're going to find the perimeter, because that's basically what we need to do if he wants to determine how much fencing he needs. This is an easy line to figure out the length of. This is a vertical line, so the distance between our y coordinates of 12 and 2 is 10. And if we keep going, we can now draw our triangles around our shape in order to figure out the value of our non-vertical or non-horizontal sides. So if we label this right triangle that we just drew over here, we're moving from 2 to 10, which is 8, or we can count our boxes, 1, 2, 3, 4, 5, 6, 7, 8. And then vertically, we're moving from 6 to 12, or we can count our boxes up 6. So if you guys are quick to see this, we know we have 3, 4, 5 right triangles. This is easily just a scaled version of that. 3 times 2 is 6, 4 times 8, or 4 times 2 is 8, so then this would have to be 10. Or if you need to see it, remember, 6 squared plus 8 squared equals c squared. C is going to equal the square root of all of this. 6 squared is 36 plus 64, which is the square root of 100, which is 10. Down here, we can do it again with our shape. We can draw our box or our triangle here, and this is going to be an 8 by 1, 2, 3, 4. So we know 8 squared plus 4 squared equals c squared. So in this case, c will be the square root of 8 squared, which is 64, plus 16, and then 64 plus the 16 gives us the square root of 80. So for our perimeter, or the amount of fencing that we need, we're going to add up our 10 plus the square root of 80 plus our other 10. So if you put that in your calculator, you're going to get 20 plus whatever the square root of 80 is. And if you put that in, you get about 28.9 feet of fencing. Make sure you have that there. So we're just using Pythagorean theorem, and we're figuring out the length of sides of our figures, adding them up and rounding at the very end of our problem. Let's use the same diagram. Let's go ahead and find the area that all these chickens would have to kind of roam around and cluck around. So we need to make sure that we remember our base must be perpendicular to our height. So we cannot take this side and multiply it by this side, because this is not 90 degrees. So whenever you're doing stuff like this on a coordinate plane, it's actually kind of nice because the grid makes your perpendicular lines easy to find. So let's go ahead and let's use this line that we used before. This was a nice vertical line, and we know that vertical lines are perpendicular to horizontal lines. But we need a horizontal line that's going all the way across our triangle to its farthest point. So if we draw this line here, that would easily be our base and our height. So we knew this was 10. Well, we can either count this here, so we could count 1, 2, 3, 4, 5, 6, 7, 8 boxes, or we could count how far is it from a positive 2x coordinate to a positive 10x coordinate, which would be a distance of 8. So this time for our area, we would do 1/2 times our base of 10 times our height of 8. Even though our triangle is sideways, base and height still perpendicular. So this time our chickens would have 40, and they told us that the dimensions were in feet, so 40 square feet of area to roam around in their pen. Last shape I want to show you is something where you know, the dimensions might not work out so well on the coordinate graph, meaning that we can't necessarily find a base and a height that are perpendicular, and we might have to manipulate with Pythagorean theorem a little bit. So this one shows a network of roads connecting 4 towns together. We're driving along each road from A to B to C to D town, and then back to A town. That means we're driving around this whole shape, and they want to know how far we drove, so we're actually finding perimeter to the nearest tenth. So if we look at our shape, this is an easy side to find the perimeter of, or the length between. So we're going to go from a +3 to a +9 horizontally, so that would be a total distance of 6. Now let's go ahead and draw our triangles for our other sides. So if we draw a triangle here, this is a 1 by 7 triangle. We can draw our triangle here. This is also a 1 by if we're going from 1 to 8, this is also a 1 by 7. And then we could go from here to here. This is a 2 by 6 triangle, because we're going to go from a 2y coordinate to an 8y coordinate. So let's go ahead. We know that the 1 by 7 triangle is also going to be the value of that hypotenuse is also going to be the same as this value over here. So we know that these two sides are the same. So if we did a little work down here, 1 squared plus 7 squared equals c squared. We know c is going to equal the square root of 1 plus 49, which is the square root of 50. So we know that this side is the square root of 50, and we know this side is the square root of 50. A little bit more work, we could do 2 squared plus 6 squared equals c squared. C is going to equal the square root of 4 plus 36, or the square root of 40. So this side would be the square root of 40. And remember, when we're finding perimeter, round at the end. So our perimeter would be 6 plus the square root of 50 plus the square root of 50 plus the square root of 40. And then if you put that into your calculator, you should get a total of 26.5 units. Make sure you have that. Last but not least, let's actually find the area of this guy. Now, base times height. So base times height of our parallelogram would make sure that we had a base and a height that were perpendicular. But this is not a parallelogram. This side is not, this side here, DC, is not parallel to AB. So we can't use that formula of base times height. So we know it's not a triangle, so we could go ahead and break our shape up into triangles and rectangles. So we could go ahead, we have a triangle here, we could keep this triangle. We might have, you know, like a rectangle going this way and all kinds of stuff. And then we could go ahead and find the dimensions this way. That looks like a lot of work, okay? So it's gonna, you know, work out sometimes where we do have to do a little bit more work, but here's another option. I'm gonna give you this as like a little tool. So keep this in your toolbox of math knowledge, if you will. So let's go ahead, let's draw a whole box around this whole shape. So if I draw a box around this whole shape, I can go ahead and find, let's go ahead, we're going to have triangle 1 on the outside, triangle 2, and triangle 3 on the outside of the shape. I can do the area of this whole box minus the area of triangle 1 minus the area of triangle 2 minus the area of triangle 3, and then I'll be left with the area of my actual shape that I care about. So the area of this whole box, let's go ahead and label some of these dimensions on here. So we knew this was a 7 by 1 triangle. We knew this was a 7 by 1 triangle. So the area of triangle 2 and triangle 3 are going to be the same. And we knew this was a 2 by 6 triangle. We knew this dimension was 6 here. So our whole box is going to be 8 by 7. So the area of this whole box is going to be 8 by 7 minus the area of triangle 1. Well, triangle 1 is this guy, so we're going to take this guy off by subtracting it. And remember, area is just base times height. Well, our base is 2, our height is 6. So minus 1/2 times 2 times 6. Now for the other two triangles, we know we have dimensions of 1 and 7, and they're both going to be the same. So minus 1/2 times 1 times 7 minus 1/2 times 1 times 7. And then we're going to go ahead and put this in our calculator. So 8 by 7 is 56, minus half of 2 is 1, and then 1 times 6 is 6, minus half of 1 is 1/2, times 7 is 3.5, and then we know this one's going to be the same. So if you put 56 minus 6 minus 3.5 minus 3.5, or 56 minus 6 minus 7, your total area of your whole shape becomes 43 square units. Make sure you have that on your paper. All right, last but not least, I want you guys to go ahead and try a couple of these on your own for homework. So in your homework, make sure you are showing all of your work, boxing your final answer. You'll scan your work, upload it, and you'll turn it into this assignment. Your homework is actually found on the next 4 slides. So here's slide number 1. If you want to pause and copy, you can, or you can go ahead and use the blank version of the notes also posted with the assignment to get those problems. Here's slide 2. If you want to pause, you can. Slide 3. And slide 4. Once you guys have that done, go ahead and submit. Thank you for listening. Have a wonderful and productive day.